Hello again, Math 10Cs. In today's lesson, we're going to continue to look at solving systems of linear equations, although now we're going to focus on doing this algebraically. And it turns out there's actually a couple of different techniques we can use to solve a system algebraically. One of them will implement a method called substitution, so that's what we're going to focus on today. And then in the next lesson after this, we're going to focus on an alternate method, which is referred to as elimination. Up until this point, we've been solving systems graphically. So the way to solve a system of equations graphically is you take your two equations, you graph them, and then you search for the intersection point. The intersection point identifies where the solution to the system of equations is. Now, if you have one intersection point, it means that your system has one solution. If you plot your lines and you have parallel lines, which means they have the same slope, the two lines will actually never intersect, in which case you would have zero solutions. And if you have two equations, but they're actually the same equation with the same slope and same y-intercept, when you plot them, they would overlap, in which case the two lines would have like infinite number of intersection points because they're overlapping. Every point on each line would be in contact. Now, for the systems we're going to look at algebraically right now, we're going to focus on ones that just have, for the most part, a single solution to them. Now, what the book does is it identifies a list of general steps we can use to solve a system of equations. So it says, step one, I want to choose a simpler equation and express one variable in terms of the other. Step two, substitute the expression from step one to the other equation. Step three, solve the single variable equation. And then step four, substitute the solution from step three into the equation in step one to find the value of the other variable. Now, at this point, these steps are just gibberish. They make absolutely no sense. So we need to actually go through an example and apply these steps to make sense of what it's trying to tell us to do. Okay, so in the first example, we have a system of equations. So we have x plus 4y is equal to 17. I'm just going to rewrite the equations out here. I'm just going to do it in a different color. So I'm going to have x plus 4y, and that's equal to 17. Now, I'm going to box this equation, and I'm going to number it. So I'm going to number this equation as equation number 1. Then I'm going to look at the second equation, and I'm going to rewrite it out, although I'm going to do it in a different color. So I'm going to say 2x minus y is equal to 7. I'm also going to box this one, and then I'm going to number it as equation number 2. So the 1 and the 2 right here are just labels. They have nothing to do with numbers in the actual equation themselves. Now, this example holds our hand a bit more because it actually tells us like how to start isolating like one of the equations. Although in the examples on the next page, we're going to have to do a little bit more of this work on our own. Okay, it says choose a simpler equation and express one variable in terms of the other. Both these equations are equally complicated. Both of them have 3 terms to it, so there's not really like one you want to start off with. So what it says here is solve the system using the method of substitution by taking the first equation. So the first equation is the one in blue, and write it in the form x is equal to. Now, what that means is it wants me to isolate x. Isolate x in the first equation. So I'm going to abbreviate equation as EQ apostrophe n. So we want to take equation 1 and we want to isolate for x in that equation. Okay, so I'll go ahead and do that. So let's write out the equation. X plus 4y is equal to 17. To get x by itself, I'm just going to subtract 4y from both sides of the equation. So subtract 4y, subtract 4y. That would then leave me with x is equal to 17 minus 4y. Now, I'm going to box this equation, and I'm also going to give it a number. Okay, I'm going to call it equation number 3. Okay, so if we go up to our steps here, it says choose a simpler equation. Okay, so I chose equation 1 and expressed one variable in terms of the other. Okay, so I did that. I expressed x in terms of y. So when it says express one variable in terms of the other, it just means isolate one of the variables. Now, step 2 says substitute the expression from step 1 into the other equation. Okay, so what I'm going to do is I'm going to take equation 3 and I'm going to throw it into equation number 2. Okay, so I'm going to write down sub equation 2 or equation 3 into equation 2. And equation 2 I just had in red here. Okay, let's write out equation 2 first though. So equation 2 is 2x minus y is equal to 7. Now, the idea here is, and I'll show this in a different color. What I want to do is I want to take this value of x and I want to throw it into the other equation in the place of x. So what I'm going to do is I'm going to rewrite out equation 2, the red equation, except in the place of x, I'm going to write down the expression that x is equal to, which is 17 minus 4y. Now, I'll try to stick with some color coding so we can kind of just see like how this works here. Okay, so this equation would be 2. Now, in the place of x, I'm going to replace it with, I'm going to sub equation 3 in here. So I'm going to replace x with, so it's not x anymore, it's going to be 17 minus 4y. Okay, and we'll close that off. Okay, so 2x minus y equals 7. 2 times x, x is equal to 17 minus 4y. And then we subtract y. Oh, I want to clear red here. Okay, we subtract y, and that's equal to 7. Okay, so this is equation 2, except in the place of x, I've just subbed in this expression, this value for x I isolated from equation number 1. Now, what we need to do is we have a single equation with one variable. So step 3 says solve the single variable equation. So what that means is isolate y and solve for what it's equal to. Now, right now we can't do that because we have some brackets, we have this minus y we have to deal with. So the first thing we're going to do to simplify this thing is just apply the distributive property to get rid of the brackets. Okay, so this would then turn this into 2 times 17 would be 34. 2 times negative 4y would be negative 8y. And then we have to subtract this y on the outside as well. So subtract y. And then this would be equal to 7. Okay, now if we just combine like terms, and then I'll move it up here, we would then have 34 minus 9y would be equal to 7. Okay, now I want to get y by itself. Okay, now it's usually it's easier to isolate for a variable if it's positive. So let's get the y onto the other side. So let's add 9y, in which case we would then have 34 is equal to 7 plus 9 times y. Okay, now we just have to apply the opposite operation to get the y variable isolated. Okay, so the first thing we're going to do is we're going to subtract 7 from both sides of the equation. So if I do that, 34 minus 7 would be 27. And then that would be equal to 9y. And then to get y by itself, we divide both sides of the equation by 9. 9 divided by 9 cancels off. And then this would tell you that the y coordinate So if we graph these two equations and look at the intersection point would have a y coordinate that would be y is equal to 3. Okay, so that's one part of my solution. Now that's step 3. Now step 4 says substitute the solution from step 3 into the equation for step number 1 to figure out the other variable. Okay, so here's the idea. I'm going to take this value of y and I'm going to plug it back into equation 3 to determine what the value of x is. Okay, so I'm going to write down sub y equals 3 into equation 3 to get x. Okay, so let's write down the equation 3. So equation 3 is x is equal to 17 minus 4y. But what I'm going to do is I'm going to replace y with 3. So I would then have x is equal to 17 minus 4. Now we know what the value of y is. The value of y is 3, so I can then just replace this y with 3 here. And then we can evaluate this. So this would then be equal to 17 minus 12. 17 minus 12 would be x is equal to 5. Okay, so the solution to this system is these two lines would intersect at the point 5, 3. So that's my intersection point. Now, we could have actually done this a little bit different in part B. So in part A, it said isolate for x in the equation. Now, part B wants us to do the same thing, except instead of isolating for x, it wants us to isolate for y. So it says rewrite the first equation in the form y equals. Okay, so what that's telling me to do is it's saying isolate y in equation 1. Okay, so let's write equation 1 out again. So that'd be x plus 4y is equal to 17. Now, given the choice between isolating for x or isolating for y, like I would always isolate for x here because it's easier to isolate for x because it doesn't have a numerical coefficient attached to it. Well, the numerical coefficient that's not equal to 1. Isolating for y is going to be annoying, so we're going to have to divide both sides of the equation by 4, which is probably going to lead to a fraction. Okay, but let's get y by itself. So we're going to subtract x from both sides of the equation. So this would then leave me with 4y is equal to 17 minus x. And then to get y by itself, I'd have to divide by 4 and then divide by 4. These 4's would cancel, and then I'd be left with a really ugly equation. So I'd be left with y would be equal to 17 over 4 minus negative x over 4 would be negative 1 over 4x. Okay, we'll box that equation, and we're going to call it equation number 3. Okay, this one looks a lot worse than the isolated x equation at the top, okay? But we're just doing it because the problem is commanding me to carry this out. Okay, now that I've isolated for a variable, so we've done step 1 now. So step 1 was choose a simpler equation, express one variable in terms of the other one. Okay, this time around I isolated for y. Now take that expression and sub it into the other equation. So I'm going to take this equation and I'm going to sub equation 3 into equation 2. And again, equation 2 is red. Okay, so equation 2 is 2x minus y is equal to 7. And what I'm going to do here is I'm going to take this value of y and I'm going to plug it into the equation and replace y with this ugly expression here. Okay, so this is going to turn it into 2x minus, okay, now we're going to sub this in brackets. So subbing it in brackets, I would then have, in brackets, we're going to place y with 17 over 4 minus 1 over 4x. Okay, and that's going to be equal to 7. Now, when you subtract an expression, you can kind of pretend like you have a -1 here. So to apply the distributive property, we just multiply both terms here by -1. So this would then turn into 2x. No, let's do it in red, just to be consistent with the color here, because we're plugging things into equation 2. So then we'd have 2x minus 17 over 4 minus 1 over 4x is equal to 7. Actually, that should be plus. Negative times a negative is a positive, so it should be plus 1 over 4x. Now, we have fractions. Fractions are annoying to deal with. So what we need to do is we need to get rid of the fractions. Now, I showed the procedure for doing this in the previous unit. So what I want to do is we're going to take the equation and multiply by the lowest common denominator of the fractions. Now, both those fractions have the same denominator, so we're just going to multiply 4 by the entire equation. Okay, so that means that we're going to multiply 4 by 2x, by negative 17 over 4, by 1 over 4x, and also by the 7. Okay, so we're going to multiply it by this, by this, by this, and also by this one. Okay, so let's carry my work up to the top so I can see it. So we go all the way up here. So this would then turn into 4 times 2x would just be 8x. 4 times negative 17 over 4 would be, okay, so negative 4 times 17 over 4. And then plus, we go 4 times 1 over 4x. So 4 times 1 over 4x. And that would be equal to 4 times 7 would be 28. Okay, now we can see that some of these numerators cancel off. So the 4 cancels off here, the 4 cancels off there. And then what you'd be left with is you would then have 8x minus 17 plus 4x is equal to 28. And now just a matter of trying to solve for x. Okay, so to do this, we're going to add 17 to both sides of the equation to get rid of the 17 from the x terms. So add 17 and add 17. And then, this shouldn't be 4x here because the 2 4s have canceled off. So we can actually just get rid of this 4. This should just be x. Yeah, because the 4 on the top and the 4 on the bottom canceled off. Therefore, you're just left with 1x here. Okay. All right, so we're going to add 17 to both sides of the equation, and then we're going to combine the x terms. So 8x plus x would be 9x. And then 28 plus 17 would be 45. And then to solve for x, we just divide both sides of the equation by 9. Divide by 9. And then this would tell me that x would be equal to 45 divided by 9 is going to be 5, which is the same x value that we got above here. Okay. Now, once you have this x value, we're then going to take it and we're going to sub it back into equation 3. Okay, so I'm then going to say sub okay, so I'm going to sub x equals 5 into equation 3 to get y. Okay, so this equation, let's write it out again. So you would have y is equal to 17 over 4 minus 1 over 4 times x. Okay, so we're going to replace, we're going to take x equals 5, and we're going to replace it with the x value here. Okay, so if I do this, this would then look like you would have y would be equal to 17 over 4, subtract 1 over 4, and in the place of x, we're gonna sub in x equals 5. Okay, so the 5 is going to go in here. Okay, let's evaluate this. So this would be 17 over 4. 1 over 4 times 5 would just be 5 over 4. And if you have 17 over 4 minus 5 over 4, we just subtract the numerator, so that'd be 12 over 4. And then 12 divides into 4 evenly, where you would get y is equal to 3. Okay, therefore, once again, the solution to this system would be 5, 3. Okay, so we've utilized the method of substitution to do this. We'll do more practice on the next page. Okay, C says verify that the solution satisfies both equations. Okay, so what we need to do is we need to plug x and y into the original equations and just make sure that both sides of the equation balance. Okay, so let's write down the two equations. So the first one is x plus 4y. X plus 4y is equal to 17. Okay, I'm going to plug into this equation x equals 5 and y equals 3. So in the place of x, we'll plug in a 5 plus 4 times the value of y, which is 3. And that's equal to 17. So this would be 5 plus 4 times 3 is 12, is 17. 5 plus 12 is 17. So you'd have 17 is equal to 17. Both sides are balanced. Therefore, yes, we did verify that the solution is satisfied. Okay, let's do this with equation number 2. So equation 2 was 2x minus y is equal to 7. Again, we're just going to sub in the values of x and y and see if both sides balance. So this would be 2 times the value of x is x equals 5 minus y, which is 3, equals 7. 2 times 5 is 10, minus 3 equals 7. 10 minus 3 is 7, therefore we have 7 is equal to 7. Okay, so that equation is also verified. And that's how you know if you solve the system correctly. If you take the values of x and y and you plug it back into the two equations, both sides of the equations have to balance in order for this to be correct. Okay, D says check the solution using a graphing calculator. I'm not going to show that, okay? What you would do is you would need to, if you want to do it, you'd have to take these two equations, you'd have to isolate for y, plug into y1, y2, you would need to plot it, make sure you can see the intersection point on the graph, so you might have to zoom out, and then you just use the intersect feature, so you go second trace, intersect feature, and then figure out what the intersection point is. But again, just for the interest of saving time, I'm not going to show it. Okay, we got another one here. It says consider the following system of equations. Solve and verify the system using the method of substitution. Okay, so once again, what I'm going to do is I'm going to start off just by boxing these equations and numbering them. So we'll say this is the blue equation. So we'll call this equation number 1. And we're going to box this equation, and we're going to call it equation number 2. Now, the instructions are in the procedure here, choose the simpler equation and express one variable in terms of the other. Now, the simpler equation would be the one that has less terms. So the first equation only has 4x and 3y, so that would be 2 terms. The 0 doesn't count as a term. And then this one would be 8x minus 9y equals 5. That one has 3 terms. So what I'm going to do is I'm going to start off with this guy. This one's a little bit simpler compared to equation number 2. Okay, so let's write this down. So we have 4, oops, I wanted to do blue for that equation. Okay, so we have 4x plus 3y is equal to 0. Now we chose a simpler equation and we have to isolate one of the variables. It doesn't really matter which variable you isolate here, whether it's x or y, because they both have a numerical coefficient attached to it. So I'll just isolate for x. Okay, so let's get x by itself, minus 3y, minus 3y. And then you'd have 4x would be equal to negative 3y. Let's get x by itself, divide by 4, divide by 4, and then I'd have x is equal to negative 3 over 4y. Okay, I'm going to box that equation, and I'm going to call this equation number 3. Okay, equation number 3. Now, after you've isolated this, you're going to take this equation and sub it into the other one. Okay, so I'm going to say sub equation 3, and we're going to put it into equation number 2. Okay, so equation 2, rewrite it out. It would be 8x minus 9y is equal to 5. And what I want to do is I want to take this equation for x and I want to sub it in here. Okay, so let's see what that looks like. So this would then be 8 multiplied by, okay, let's write this in brackets here. So we're going to replace x with negative 3 over 4y because that's what x is equal to. And then we're going to subtract 9y, and that would be equal to 5. Okay, we can multiply this out now. So this would then be 8 times negative 3 would be negative 24. So you have negative 24 over 4y minus 9y is equal to 5. Now, thankfully, this fraction divides evenly. So negative 24 divided by 4 actually gives you negative 6y. So let's pull it up here. So it would give you negative 6y minus 9y is equal to 5. Okay, we can combine like terms on the left-hand side. So this would turn into negative 15y is equal to 5. And then to get y by itself, divide both sides of the equation by negative 15. Divide by negative 15. The negative 15s would cancel off. And then what we get is we'd have a fraction that is y is equal to 5 over negative 15. If you reduce this fraction, though, you could divide both the top and the bottom by 5. And let's move the negative sign to the top. So this would actually turn into negative 1 over 3. Okay, so that's what the y coordinate would be equal to. Now, after we've done that, you then take this value of y and sub it back into equation 3. So I'm going to sub y equals negative a third into equation 3. Okay, so equation 3 is x is equal to negative 3 over 4y. So we're going to take this y value and we're going to plug it in right here. Okay, so this would then become x is equal to negative 3 over 4 multiply by, and let's plug in the value of y, so y is negative 1/3. And then negative 3 times negative 1 would be positive 3. And then 4 times 3 would be 12. This fraction would reduce. If you divide both the top and the bottom by 3, it would return into 1 over 4. Therefore, my solution to this system would be an ordered pair. That would be 1 over 4 and negative 1 over 3. Okay, so I'll just go ahead and box that. Okay, as for verifying the system, I guess I should do it. I really don't want to. Okay, so again, to verify, we just need to plug the values into both equations and make sure that both sides balance. Okay, so let's just do it over here. Okay, so the first equation is 4x plus 3y equals 0. Okay, so we're going to plug in. The value of x is 1/4 plus 3 times the value of y, which is negative 1/3, is equal to 0. Okay, so this would turn into 4 over 4 minus 3 over 3 equals 0. 4 divided by 4 is 1, minus 3 divided by 3 is 1. Therefore, both sides of the equation would be equal to 0. So that equation is verified. Okay, let's verify the second equation. So you have 8x minus 9y is equal to 5. Again, we're going to plug in those calculated values of x and y. So x is 1/4 minus 9 times y is negative 1/3, and that's equal to 5. So this would give you 8 over 4. Negative 9 times negative 1 would be positive 9. So you'd have positive 9 over 3 equals 5. 8 divided by 4 is 2. 9 divided by 3 is 3 equals 5. And then 2 plus 3 is 5. Both sides of the equation are equal. Therefore, it's verified. Okay, B says check the solution of the graphing calculator. Again, if you want to do that, go ahead. You'd have to isolate for y, plug them into y1, y2, use the intersect feature to figure out what the intersection point is. Albeit you're going to get the intersection point as a decimal number, so you'd have to take the x and y values and you'd have to turn them into fractions. Okay, last one. This is considered the following system of equations. So once again, we'll start off just by boxing these things. Okay, so we're going to call this one the first equation number 1. And then we'll call the second equation equation 2. And solve the system using the method of substitution, and then verify algebraically. I think this time around, we're just going to skip the verification. Again, the verification just involves once you get the values of A and B, just plug them back in and see if both sides are equal. I just want to save a little bit of time here. Okay, so step 1 is we need to choose the simpler equation and isolate it. Both these equations are really ugly. They both have brackets. There really isn't there isn't one equation that I would say is more simple than the other one. Maybe the first equation, just because the variable b is by itself, as opposed to this equation, the a is not by itself, and the b, once we use the distributive property, it's not going to be by itself. So let's do equation 1. Okay, so we would have, let's do blue again. So I'd have 5, and then 2a minus 3 plus b is equal to 5. Now, I'm going to isolate for b because that's the easiest thing to do. But even before I can isolate for b, I do need to simplify this a bit. So I need to get rid of the brackets. So I'll apply the distributive property. So 5 times 2a would be 10a. And then 5 times negative 3 would be negative 15 plus b. And that would be equal to 5. Okay, so let's get b by itself. So to get b by itself, I would need to add 15 to both sides of the equation. So add 15, and we have to get rid of this 10a term. So we're going to subtract 10a, and we're going to subtract 10a. So on the left-hand side, I'd then be left with b is equal to 5 plus 15 is 20, and then subtract 10a. Let's rewrite that out so it's not so messy. Minus 10a. Okay, I'm going to box this equation, and I'm going to call it equation number 1. Now, what we do is once we isolate for that variable, we then sub it into the other equation. Now, I don't want to sub it in right now because I already have brackets, and if I sub it in, I'd actually have 2 sets of brackets. So let's simplify this thing first before we actually sub it in. Okay, so second equation is, oh, sorry, just for a second, it froze up. Okay, so the second equation is 6a minus 2b minus 4 is equal to 20. Okay, let's get rid of these brackets. So distributive property. Now we have to apply this negative as well. Okay, so it's going to be negative 2 that applies to both things in the brackets. So this would turn into 6a minus 2b. Negative 2 times negative 4 would be positive 8. And that would be equal to 20. Okay, so 6a minus 2b plus 8 is equal to 20. And then now, what I'm going to do is I'm going to take this equation, b, and I'm going to sub it into, so I'm going to take this here, and I'm going to sub it in the place of b right there. Okay, so then, I can even write that down. I can say sub, oh, let's call this equation 3 here, not 1. Already labeled 1 at the top. Okay, so you got equation 3. So we're going to sub 3 into the modified version of equation 2. So modified version of equation 2, we're then going to have 6a minus 2 times, now we're going to plug in b with this expression here. So then that's going to turn into minus 2, and then 20 minus 10 times a. And then we still have this plus 8 here as well. So plus 8 would be equal to 20. Okay, we got to get a by itself now. So distributive property, apply this negative 2 to both things on the inside here. So then this would turn into 6a minus 40. Negative 2 times 20 is negative 40. Negative 2 times negative 10a would be positive 20. A. And then plus 8 would be equal to 20. Okay, let's simplify this by collecting like terms. So 6a and 20a would be 26a. And then negative 40 plus 8 would be negative 32. And then that's equal to 20. And now we just have to get a by itself. So to get a by itself, we're going to add 32 to both sides. Add 32. So then we'd have 26a would be equal to 52. Solve for a, so we divide by 26. Divide by 26. Sorry, this is a 2 here. 26 is cancel. and then 52 divides evenly into 26, it would give you A is equal to 2. Now to calculate the value of B, we're going to take this value of A and throw it back into equation 3 here. Okay, so I'm going to sub A equals 2 into equation 3 to get A. Okay, so if I sub that back into the equation, then it would be, my equation is B is equal to 20 minus 10 times A. So that would be B is equal to 20 minus 10 times A is 2. So this would be 20 minus 20, which tells me the value of B would just be equal to 0. Therefore, my intersection point, which is the solution of the system, would, well, it depends. If you write it in like the ordered pair of like A, B like this, it would then be 2, 0 as my solution. And again, if you want to verify this, you just have to take the value of B, plug it into these two equations, take the value of A, same thing, plug it into these equations, and just see if you can get both sides of the equation balanced. And if they do, it means that you did solve the system correctly. Okay, we're not going to do this. This is actually a system of 3 linear equations. Like I said, it's a bit of a nightmare to do it. Okay, so what you can do for practice is just do numbers 1 and 2. And just verify for number 1, okay? Okay, and that's it for this lesson. And then the next one, we'll talk about how we can use an alternate approach, the method of elimination, to solve a system of equations. And I'll talk to you then.